Hello and welcome to Radicals number 5. So today we are going to take a break from simplifying radicals and using our radical rules to solving radical equations. So what that means is that we are going to be given equations that have roots in them. So square roots, cube roots, fourth roots, and so on. So the step-by-step is going to be just like it is when we have just a regular square root. You are going to isolate the radical, which means the root, on one side of the equation. Then you are going to raise each side of the equation to the power of the index, which is going to kill off the radical sign. So what that means is we are using an inverse operation to kill off the square root or the cube root or the fourth root. So the inverse operation that we are going to use depends on what kind of a root it is. If it's a square root, we're going to square both sides because a square and a square root kill each other off. If it's a cube root, we're going to cube both sides because a cube root and a cube kill each other off. If it's a fourth root, we're going to raise both sides to the fourth power because a fourth root and a fourth power kill each other off. I think you get the idea by now. So the key here is each side. We're going to do that too. And then we are going to solve just like we normally do. And then here is the big one. We have to check for extraneous answers or solutions. So one of the major problems with square roots is they create false answers. I know that I'm always preaching about checking your answers, check your answers, check your answers, use your calculator, use Desmos, okay? And I know that a lot of you don't. What I'm telling you right now is that you have to, because the answers that you get, one of them could be false, two of them could be false. You have to check your answers to be able to know what is an actual good answer versus what looked like a good answer but actually is not. So you have to check your answers on these. You have to. Okay, here we go. So we're going to isolate, we're going to use an inverse operation, and then we're going to finish up solving. So I need to isolate. That means that I need to get this square root of x by itself. How do I do that? Well, I'm going to subtract 5 on both sides. So that's going to give me a square root of x equal to 12 minus 5 is 7. So now I need to get the x by itself, and I need to kill off the square root. How do we kill off a square root? With a squared. What you do to one side, you must do to both sides. So we are squaring both sides. The square is going to knock out the square root, leaving us with x. And then 7 squared, that's 7 times 7, that is 49. Now, you're going to want to check that answer. So if I plug in a square root of 49 and then add 5 to it, I better get 12. Yes. All right, number 2. I need to get this by itself. Now, because I am subtracting it, if I add this thing over here, that is going to give me a positive fourth root of m, and positive numbers are always better to work with. So that is my plan of action. I am going to add the fourth root of m on both sides. So that's going to leave me with a 3 equal to 0 plus the fourth root of m is the fourth root of m. Okie doke. Now I need to get m by itself, which means I need to kill off a fourth root. How do I kill off a fourth root? By raising it to the fourth power. Notice how those numbers are the same. They're always going to be the same. What I do to one side, I must do to the other. So 3 times 3 times 3 times 3, that is 81. A fourth power is going to kill off a fourth root and leave us with m. Oh, I forgot to mark that. I checked that. So here is my final answer, 81. And now I am going to check it. So I'm going to plug in 3 minus the, you have to use the math, the fourth root of 81 should be 0. Yay. No false answers yet. All right, next one. I need to get the root by itself, which means that this 10's got to go. How do we do that? Subtracting 10 on both sides. So the square root of a plus 7 is equal to 11 minus 10 is 1. And now we have to get rid of the square root. How do I kill off a square root? By squaring it. Square on both sides. So the square root is going to kill off the squared and leave us with a plus 7. 1 to the second power, that's 1 times 1 is just 1. And then we finish up. I'm subtracting 7 on both sides, so I get a final answer of a equals 1 minus 7 is negative 6. Let me check that. 10 plus the square root of negative 6 plus 7. And that better equal 11. Yep. And I'm doing this on my calculator, but you can enter that into Desmos and it will crunch that out for you. So this one has been checked and it is good. Okay, remember, you are pausing these videos and you're working ahead of me. When you feel confident that you can do it, go ahead and do it by yourself so that you can check your own understanding. I need to get the square root by itself, which means that 10's got to go. Subtracting 10 on both sides. So that's going to be the square root of 6w minus 5 equal to 3 minus 10 is a negative 7. All right, now that square root has got to go. How do you kill off a square root? Square it. Both sides. The square root and the squared are going to kill each other off. So 6w minus 5 gets left behind. Be careful here. This is a negative 7 squared. A negative 7 times a negative 7 is a positive 49. Let's keep solving. I need to get w by itself. I'm adding 5 on both sides. So 6w is equal to 54. And then dividing both sides by 6, I get w is equal to 9. All right, so now I check it. I've got the square root of 6 times 9 minus 5, and then add 10 to it, and that should be 3. Uh-oh, it's not. What does that mean? I've checked this answer and it did not work. So my first thought is maybe I plugged it in wrong. All right, if I plug it in, 6 times 9 is 54, and then 54 minus 5 is 49. So that should be the square root of 49 is 7, and then 7 plus 10, yep, that is 17. What does that mean about 9? It means that that is not a good answer. That means that that is a false answer, so there is no real solution to this problem. There is no real solution. When I checked this, 9 was not an answer. Now, if you are in the habit of just getting an answer and moving on, 9 is beautiful. Why wouldn't you think that that is Or why would you think that that was a false answer? It's so important that you are checking all of your answers. Okay, so I need to get this quantity here by itself. Now, you know what a half power is. A half power, it's power divided by root. That's actually a square root, okay? It's a different way of writing it. It's a fractional exponent, but this thing is a square root. So the first thing I'm going to do is get rid of this -9. It's being multiplied, which means that we need to divide it. So -36 divided by -9 is a +4. And then instead of writing it as a fraction exponent, I'm going to write it as the square root of c minus 12 raised to the first power. So just c minus 12. Okay, now it makes it a little easier to see. So I have to get rid of this square root. How do I get rid of a square root? Square it. Square it on both sides. So 4 times 4 is 16. Square and square root kill each other, and we have c minus 12. So final step, I am adding 12 on both sides. 16 plus 12 is 28, and that is equal to c. All right, let me check that. Now, if you're worried about plugging it in wrong, we'll just use it exactly as you see it. So -9 parenthesis, 28 minus 12, close the parenthesis, raise it to the 1/2 power. I'm typing it in exactly as it was presented to me. That should equal -36. All right, cool. All right, number 6. Yeesh. 1/3. Oh, that's no big deal. Power divided by root. That's actually a third root or a cubed root of 7p minus 1. I need to get that by itself, so I'm going to start by subtracting 11 on both sides. 7 minus 11 is a -4. All right, so I've got this cube root. How do we kill off a cube root? Cube it. Raise it to the third power, both sides raised to the third power. So the cube root and the cube are going to knock each other out and leave you with 7p minus 1. -4 times -4 times -4 is a -64. Let's keep going. I'm adding 1 on both sides. Be careful with the negatives. That is going to be -63. And then divide both sides by 7. So final answer, we get a p of -63 divided by 7. That is -9. All right, let me check that. Again, I'm going to type it in just exactly as I see it. You can do it in Desmos that way as well. So 7 times parentheses, 7 times -9. And then minus 1, close the parentheses, raise it to the 1/3 power, arrow out plus 11. That should be equal to 7. Sweet. Number 7. I need to get this 4th root. I guess I should have highlighted that one too. I need to get this 4th root by itself. So that means that that -9's got to go. Adding 9 on both sides. 4th root of 8k plus 12 is equal to -11 plus 9 is a -2. I need to kill off the 4th root. We do that with a 4th power on both sides. 4th root and 4th power knock each other out. 8k plus 12 is equal to -2 times -2 times -2 times -2, which is positive 16. Keep going, subtract 12 on both sides. So 16 minus 12 is 4. And then divide both sides by 8. So we get 4/8, which simplifies to 1/2. 1/2. Now remember, in your calculator on Desmos, you can use 0.5 because that's easier to punch in. All right, let me check it. So math number 5, I need a 4th root of 8 times 0.5, half, right? Plus 12, arrow out, minus 9, and that has to equal negative 11. Nope. Did I mess it up when I put it in? Let me do 8 times 1/2 is 4, and then 4 plus 12 is 16. So then it would be the 4th root of 16, and then subtracting 9. Yep, that is a -7. That is not negative 11. What does that mean? That means that this is a false answer, and there is no real solution. All right, I need to get this square root by itself. So there's a couple things that gotta go. The -4's gotta go and the 18's gotta go. Who goes first? The 18. I'm gonna subtract it on both sides. So -4 square root 43 minus 3x is equal to -2 minus 18 is -20. So my job is not done. I still don't have the square root by itself. I've got to get rid of multiplying by -4. How do I get rid of multiplying by -4? Divide by -4. So now I have the square root of 43 minus 3x equal to negative divided by negative. That is a +5. All right, so now that my square root is all by itself, how do we knock out a square root? Square it. Power up both sides. Square and square root are going to knock each other out. So that's going to be 43 minus 3x equal to 5 times 5 is 25. And then subtracting 43 on both sides, 25 minus 43 is a -18. Divide both sides by -3, and I get an x equal to +6. All right, so let me check that. -4 square root 43 minus 3 times 6. Add 18 to it, needs to be equal to -2. So getting the square root by itself, using an inverse operation to kill off the root, and then solving like normal. Taking care to check for your false answers. I really would like you to pause the video, move on, do a handful on your own, and then go ahead and play me. I am going to do the next 4 by hand, and then I want to show you here on the last 6 how you can do it by calculator or on Desmos. So I'm going to show you on your calculator and on Desmos how to work these out. So let me finish up these 4 here by hand. And then I'll show you how to put it in your calculator or on Desmos. Okay, so what the heck is different about number 9? Holy smokes, we have 2 square roots. Well, I've got one by itself here and I've got one by itself here, so we are in really good shape. How do I kill off those square roots? Square it. And you're going to find something really amazing happens. The square knocks out the square root here, u minus 8. And the square knocks out the square root here, 43 minus 2u. Amazing. Now I got to get my u's together. I'm going to move the smaller one, adding 2u on both sides. 1u plus 2u is 3u. Adding 8 on both sides. 43 plus 8 is 51. And then divide both sides by 3. So 51 divided by 3, I get a U value of 17. Okay, so this one, I'm going to have to check both sides and then make sure that they equal the same thing. So what was it, 17? So the left side is square root 17 minus 8. That's the left. And then the right is 43 minus 2 times 17, and that's the right. The left and the right are equal to each other, so I know that that checks out. All right, next one. I've got a fourth root and a fourth root. Both of them are by themselves. They are equal to each other. I am good to go. How do I get rid of a fourth root? Raise it to the fourth power on both sides. The fourth power and the fourth root are going to knock each other out. Again, the fourth power and the fourth root are going to knock each other out. And now I need to get my d's together. I'm going to move the smaller of the d's, plus 2d on both sides. So 27 is equal to 1d plus 2d is 3d. Adding 3 on both sides, 27 plus 3 is 30. And then divide both sides by 3. So 30 divided by 3 is 10. Let me plug in. I need math, and number 5, I have a fourth root of 27 minus 2 times 10. That's the left side. I need a fourth root of 10 minus 3. That's the right side. So both sides are equal to each other. That one looks good. Okie dokie. So I've got a square root and a square root, but I've got my numbers out in front here. So I can do a little something about that. I can get rid of this 4 here by dividing both sides by 4 to start. So watch what happens. Those 4s get knocked out, which is the square root of 3q plus 15 equal to 12 divided by 4 is 3. So I wasn't able to get rid of all of my numbers, but I definitely made this more simple. Okay, here's the tricky part. I know that I have to square to get rid of a square root. Left side is easy. Square and square root knock each other out. Here you have to be careful. It's 3 square root q times 3 square root q. So that 3 has to get multiplied out 2 times, which is 9. And then the square is going to knock out the square root, which is just q. So you have to slowly think your way through that one. I'm going to move the smaller of the q's. So I am subtracting 3q on both sides. So that's going to be, what, 6q? Divide both sides by 6. So I get a q of divisible by 3, divisible by 3. So that's going to be 5 halves. Ugh, 5 halves. When I do 5 halves, that's actually 2.5. So I'm going to use that when I check it. So 4 square root 3 times 2.5 plus 15 more. That is the left side. I've got 12 square root 2.5. That is the right side. Always try to make it easier for yourself. Like if that would have been 5/3, well, that's a repeating decimal, and then you would have had to use 5/3 when you checked it on your calculator. If it's a nice terminating number, then you can always plug back in using the decimal version. Okay, so last one by hand. So I noticed that both sides are a cube root, and there's nothing that I can do to get rid of that -2 right now. So how do I get rid of a cubed root? Cube it. Left side is easy. The cube and the cube root are going to knock each other out. Now you need to think about this. It's -2 cubed root of n times -2 cubed root of n times -2 cubed root of n. So that -2 is getting multiplied out 3 times. -2 times -2 times -2 is -8. And then the cube root and the cube are going to knock each other out, which is just n. The smaller of the two n's, I'm going to add 10n on both sides. So negative 8 plus 10 is 2n. Divide both sides by 2, and I get 7. All right, let me check it. If you think like, oh my gosh, why is she checking every single answer? It's because I have to. When I'm solving equations like this, the potential for me to be producing false answers is very, very likely. So I have to check every single answer. Even if I feel like uber confident that I've done it right. When am I plugging in? 7. I can't just allow myself to be comfortable in thinking, yes, I've done everything right, because you can do 100% correct math and still produce a false answer on these. So you have to check yourself. Good? Okie dokie. So on these last 6, I just want to show you quickly how to put these into your calculator or how to put them in on Desmos in order to find solutions. So what you're going to do is you are going to get one side to equal 0. You are going to get one side to equal 0. So I would subtract x on both sides here, which would give me square root 8x minus x is equal to 0. Because we are now equal to 0, that means on your calculator or on Desmos, you are now going to find your zeros. There's another word for that. What's another word for zeros? X-intercepts. There's another word for it. Roots. There's another word for it. It's the last word. Solutions. All 4 of those words means the same thing. But once you are equal to 0, once you are equal to 0, that is what you are doing, is you are finding zeros. So let me show you on the calculator. So I am going to put this into y equals, and I'm doing the square root of 8x, arrow out, minus x. And then I'm going to go and graph it. So I'm looking for my zeros. I'm looking for my x-intercepts. So I know I have one right there. And I don't know if I have them right there. So sometimes the graph isn't the best place to look. Sometimes it's easier to look at your table of values, because in an x-intercept, you should have no height, which means that you should be looking for a y value of 0. So that means that x is 0. Here's another y value of 0. So that means that x is 8. Ladies and gentlemen, there are 2 answers here. You have roots at 0 and 8. So you can write that as 0 and 8. I've confirmed by looking at my graph, by looking at my table of values. So if you want, you can algebraically plug these back in. That would be the square root of 0 is equal to 0. Yeah, that makes sense. That would be 8 times 8. So the square root of 64 is 8 equal to 8. Yep, that makes sense. So you can plug them in algebraically to check your answers. Okay. Let me do this one. I'll do it on Desmos. So I am going to y equals, let's see. Oh, I have to, go back. I have to make it equal 0 first, right? That's the only way I can find zeros, which means that I need to be subtracting 8a on both sides. So square root 12 minus a, positive 7a minus 8a is a negative 1a. Now that I am equal to 0, now I can go plug that in on Desmos. Okay, try again. So y equals the square root of 12 minus, I'm not going to use A's like in my calculator or on Desmos. I'm just going to use X. Everything is built in X's and Y's when I'm on a graphing calculator. So 12 minus X, arrow out, minus 1X. So I am looking for my X-intercepts. I want to make sure that I don't have a whole bunch. So I'm zoomed way out. Look at 100, negative 100. I only have one X-intercept, and it is right there at 3, 0. So that means that I have one root at X equals 3. Because on Desmos, it showed that my one root, or my X-intercept, was at 3, 0. So X equals 3 is my final answer. And then I can check that easily. I can do the square root of 12 minus 3, add 7 times 3 to it. That's the left side. And then on the right side, 8 times 3 is 24. So that works out. All right, number 15, I have to make it equal 0 first. So I am going to subtract m on both sides, and I am going to add 5 on both sides. So that's going to give me the square root of 6m minus 38 minus m plus 5 equal to 0. I'll do this one on my calculator. Why not? All right, so y equals, so that's going to be the square root of 6x. Remember, I'm not using m's, I'm using x's and y's. So 6x minus 38, arrow out, minus x plus 5. And then I'm going to take a look at my graph. I'm looking for my zeros, my x-intercepts. Ooh, looks like they're going to happen somewhere in there. I can probably get a better look at that on my table of values. Boom, there's one. Do I have another one? Yes, I do. So I have x-intercepts at 7 and 9. So 2 answers here. 7 and 9. All right, let me check them real quick. So I've got square root 6 times 7 minus 38. That is the left. And then 7 minus 5, that's the right. So 7 checks out. And now 9. So 6, oh, sorry. Square root of 6 times 9 minus 38. That's the left. And then 9 minus 5, that's the right. All right, cool. So both of those numbers check out. All right, number 16. Let's see. I need to subtract v on both sides, and I need to subtract 2 on both sides. So square root 2v plus 3, and then we have a minus v, and then a minus 2 equal to 0. Notice how these numbers never make it underneath the square root. Those two things are absolutely different things. They cannot be combined together. I'll put that in on Desmos. So I am equal to 0, which means that I'm going to be looking for zeros. So that's going to be y equals square root 2x plus 3, and then minus 1x, and then minus 2. So I'm looking for my zeros. I'm super zoomed out here. It looks like they're going to be maybe 1, maybe 2 in there. I need to get way better zoomed in so that I can see them. I can zoom way, way in. Looks like it's just going to be that 1 right there at -1, 0. Ladies and gentlemen, remember, you can look at a table of values for this. If you go to your gear and then say, hey, I don't want to look at the function, I want to look at the table of values, you can see your table of values. So right here at -1, 0, you know that that is going to be your x-intercept. Oh, I just lost it. There we go. So x is -1. x is -1 is our solution, and then let me check it really quick. Square root of 2 times a -1 plus 3, that is the left side, and then -1 plus 2, that is the right side. They equal each other, so that is a good solution. All right, last two. If you haven't paused me and then moved ahead, you should probably do that right now. I'll just finish these up on Desmos. That's what most of you have at home. So I need to subtract y on both sides, and I need to add 11 on both sides. So that's going to be the square root of 51 minus 5y minus y plus 11 is equal to 0. And this method, guys, that I'm using right here about putting it equal to 0 and using Desmos or your calculator, that will solve these guys too. Okay, it is a way for you to use technology as a tool. And as I've talked to you before, sometimes the tool slows you down. Sometimes it's easier just to do things quick and easy by hand. And sometimes functions are a little bit more complicated, and it's actually easier to use the tool. I'm talking and I'm not paying attention. I just put in a 5y. I want a 5x. And then minus x. I hope I finished my thought just now, and I totally don't have my y equals. Y equals. Okay, there we go. So I am way too zoomed in here, so I'm going to use my little scrolly wheel guy, and I'm going to back it up. And, oh, there it is. Hey, what does that mean? What does it mean that it's never coming down and touching the x-axis, ever? Look at, I'm super zoomed in. Huh. Table of values? Does that help me? I guess I'd have to go way down here to whatever that is. What does it mean that it doesn't touch the x-axis? That means that there is no real solutions to this problem. I don't have any x-intercepts. I don't have any zeros, and that's what I'm looking for. So there's no real solution here. Okay, last one. It's like the ones at the top of the page, but I will use technology to solve this. So I need to, oh, I guess it's not, because that square root doesn't come all the way over. I lied. It's not like that at all. I'm going to subtract a square root of x on both sides, and I'm going to add 1 on both sides. So square root of x plus 9 minus a square root of x plus 1 equal to 0. Remember, those two things are not the exact same things, therefore you are not allowed to put them together. They must stay separate. Okay, so x plus 9, and then I need another square, oops, try again, square root of x, and then this needs to be a plus 1. All right, so let me find my graph. I'm going to back it way out. There it is. Holy smokes, it looks like I'm getting closer to the x-axis. Clicking and dragging, clicking and dragging. Maybe I need to back it out even more. I still need to be able to see it. Oh man. Huh. Well, it doesn't look like, look at, I'm out at 2000s. It doesn't look like I'm ever coming down to touch anything. Like I keep getting closer and closer to a y value of 2, but I'm not getting any lower than that. What does that mean? That means that I'm never going to touch the x-axis, which means that I'm never going to have a 0, which means that I have no real solution for this. So use your tools as they benefit you. Use the calculator, use Desmos, use your brain, and do things by hand. Find the most efficient way depending on the problems that you are given. I believe that the next lesson is our last lesson in radicals. Yay, see you soon.